All right. Hello, everyone. And this is going to be another live stream. Still trying to kind of burn through all of the remaining bugs and bugs and new features ahead of the Incus 05 release. So today's going to be one that's more focused towards virtual machines, specifically around the VM agent. And the remaining other issues, I'm not sure. I might just do them on my own time here and there. Or maybe I'll do a live stream tomorrow on the cluster stateful VM part of it. We'll see. Anyways, so yeah, that's just 3 issues left at this point before Incus 05. That's pretty exciting. It really is looking like an amazing release. There's a lot of new features in there, and yeah, I think it's going to be a good one. Also, for anyone using Debian, there is now Incus 04 packages directly in Debian unstable and testing. And the interesting consequence of it being in Debian testing is that it got also included into the Ubuntu development release. I don't know if it got fully published yet. We can check that easily enough. So if I look at the Ubuntu archive, let's see what that looks like. It's possibly still in proposed, which would just kind of mean it needs to go through testing and some other stuff before it gets pushed into the development release. But let's see. All right, so yeah, it's currently in Noble proposed. So that's development release, proposed bucket, in universe with binaries available on all architectures. So I think it just kind of needs to go through automated testing and stuff, and then it's gonna move to Noble itself. That's pretty interesting. It did need a tiny change for 0.4 to work properly in Ubuntu, but that's gonna be changed very soon with 0.5, where we've effectively done some changes in upstream Incus so that the package as it goes in Debian can go directly into Ubuntu. So if we do the same query against Debian itself, we can see here that Incus 04, so the exact same one, is currently available in Debian testing and unstable. So that's pretty exciting stuff. I'm still going to make my own packages. That's not going to be changing really, because my own packages are targeted at Ubuntu long-term support releases, and they're also a bit different in that those packages embed everything. So my packages come with built-in QEMU, with built-in LXC library, and with a number of other libraries and support components all built together and tested together. It's a bit different from the normal distro approach, where in the distro, it just depends on the other packages. So the Incus package depends on the normal QEMU package, which depends on the normal EDK2 firmware package. And that can work and sometimes doesn't. So it kind of depends. For example, things like secure boot firmware or TPM validation in the firmware could be lacking or not be properly tied together and that kind of stuff. So anyways, it's really exciting that native packages are becoming available in a wide variety of distros now for Incus. Definitely great to see that Debian and as a consequence Ubuntu are getting a native package as well. And yeah, my packages will remain available for something that's kind of end-to-end tested with everything kind of bundled together, and it's just kind of a different offering than what the distros offer. So that was just a bit of an aside, but definitely an interesting development here. As far as, again, what's left for 0.5, so Incus 05 is meant to be released on Thursday, with probably the announcement videos and all that stuff coming out on Friday, kind of as usual. As mentioned, we've got 3 issues left, so today we're going to be looking at the VM Agent 1, which is the 3rd one on that list, and I'm going to be looking at the other 2 probably just kind of here and there as I've got time until then. So what's going on with the VM Agent? So it's probably going to be a bunch of backstories on just how that stuff works. For anyone not familiar, the VM agent is how we get virtual machines inside of Incus to behave effectively like containers. You can do exec against them, you can transfer files, you can do all that kind of stuff, and that's facilitated by an agent running inside of the VM. Now, unlike the VirtualBox or VMware model, where you need to manually go and install a package inside the VM so that it has an agent running that can then interact with the host system, we've got something a bit different, where we effectively expose a config drive to the VM that includes the agent, configuration key, configuration files, crypto keys, and that kind of stuff to actually establish the connection. And that works really well. The issue is that currently we only expose a single Incus agent through that. And we don't expose it in a particularly great way. What I mean by that is if we go look here, and actually let me just go to a demo project. What do I have in there? Nothing. Good. So if I just launch an Ubuntu VM, crap, I already have that name used in another VM. Oops. Yeah. So let's try it again. Let's call it, I don't know, V2. There we go. What happened here is if you've got a V1 VM probably in a different project on the same machine, so there's a DNS conflict. So with that VM, now it's up and running. As mentioned, all I'm doing here is actually done through the agent that's running here. If that agent wasn't running, we wouldn't get anything. You'd need to like sort out either through the VGA console or text console, like sort out a normal login and password type thing, or use SSH against the VM to get in. So we're going through the agent. The agent uses, as mentioned, a config drive to pass in some details. So if we mount that config drive and go see what's in there, we can see that there's a list, like a JSON file with a list of mounts. In this case, there's nothing because I'm not passing in any directories from the host system into the VM. But if I did, that's where they would be. There's an agent configuration, which mostly tells it what address to use to connect to the host system. And then we've got an agent certificate and key. That's what's used to authenticate against the host system. And lastly, server CRT, which is the certificate of the host system itself. So as you can see, this is effectively all SSL TLS type stuff. It's not done over the network, at least not a traditional network. It's done over something called VSOC, which is an internal in-memory networking between the VM and the guest, between the host and the guest. The interesting side effect of that is we can actually have a VM with completely broken networking and the agent works perfectly fine despite that. On top of that, we've got a directory with a number of files. Those files would be the kind of templated files, so your host file, host name, those kind of things. So that's kind of the same type of templates as would normally be used for containers, but in the case of VM, they're pre-rendered by Incus and then exposed to the VM through the config drive, and then the agent pushes that in the right locations on first boot. Incus agent itself is the binary, so that's what's currently running. And effectively, it means that for every single VM you run, we currently have a copy of the agent taking about 12 megs. That's not ideal. That's one of the things that hopefully this work will also fix. Next would be network configuration details that you can pass through the agent. That's not done by default. And then you've got systemd and udev, which include some of the files if you needed to install the agent manually. So if you're using a VM that doesn't have the agent at all, you can log into that VM through the graphical console or through SSH or something like that. Then mount that config drive the same way I did it, and then you run the install.sh script that copies the loading systemd units. Then you can reboot and you get the agent embed running. So that's how that stuff works. The main issues we have and want to fix here are, first of all, every single config drive has a copy of the agent. That means we need to copy those 12 megs every time a VM starts. There's a bit of logic to try and optimize that, so we don't needlessly copy the same file over and over again, but it still needs to happen, and it's still wasting time and space. The other issue is that binary. There's just one of them. So in this case, it's going to be a Linux. No, I don't have the file command. Okay, let's install it. So in this case, it's a Linux binary. And it's going to be actually a Linux 64-bit Intel binary, because that's what my host system runs. So we effectively assume the guest runs the same thing, and that's the only thing that's exposed. Now, if the guest was running, I don't know, 32-bit, like a 32-bit operating system, that wouldn't work. If the guest was running, say, BSD or another operating system, that also wouldn't work. So one of the goals of behind this issue is to actually make it so we expose multiple agent binaries that can give a variety of operating systems and architectures, so the guest can pick up the right thing. What I'm going to be setting up today is what should actually work, which is just Intel 64 and 32-bit. Because I can easily create a 32-bit virtual machine and show that that the agent currently doesn't work, and then work on making that actually behave. There's not much point in doing things like having an ARM binary on Intel, because we don't allow that kind of emulation. We only allow KVM, so CPU optimized virtualization, which means you don't get to run a completely different architecture. But having the 64 and 32-bit version of the binary makes sense. Just as once someone manages to build the agent on other operating systems, I think someone was looking at building on BSD, then a BSD version of the Incus agent binary would make sense. And again, if at that point, if you install a BSD virtual machine, that would run that version of the agent. So that's the general idea. Now, on how to actually do this? Well, the first thing we need is a virtual machine that doesn't work. So let's work on that. I'm gonna go and quickly download, what can we get? Let's do Debian install. Because Ubuntu doesn't build 32-bit and it hasn't been for a little while. So instead of installing like an old Ubuntu, we should probably be able to get a modern Debian 32-bit, because I believe they still support it. They probably don't support it very happily, because I think it's kind of going away everywhere, but they still have it. Yeah, there we go. 32-bit PC, let's install ISO. So I'm just going to be downloading that real quick here, and then going to be using Incus's CSM support. So that's the ability to boot like an old BIOS type image, to boot that particular image and install it. That's because 32-bit doesn't really have EFI support. I know it's not strictly true. There is 32-bit EFI, that's a thing, and it existed on some netbooks and some other platforms, but by and large, it doesn't really count. Pretty much all modern platforms have a 64-bit BIOS, 64-bit EFI BIOS, which expects to boot 64-bit EFI binaries. If you've got a 32-bit operating system, that's not gonna have a 64-bit EFI binary to boot it, so it doesn't work. So for that, we're going to be using CSM, which allows for booting a legacy style BIOS directly from Incus, which does get us effectively 32-bit BIOS style boot, and that will let us boot this particular thing. So just 6 more seconds for it to finish downloading, and we should be able to create something. There we go. Okay. So let's just create an empty virtual machine. So we'll do empty, and let's do Debian 32 as a name, and we want that to be a virtual machine. Okay. And we need security secure boot disabled, and we need security CSM enabled. Okay. Now next step is we need a boot drive. So let's just call it install. This is a disk, and the path is gonna be in my downloaded files, and we're gonna want to boot from this thing, so put a high boot priority. Config device add. What is complaining about? Disk entry is missing. Oh yeah, right, it's not path, it's source in this scenario. Let's just fix that. Source. There we go. Okay. So do Debian 32, and I want a VGA console. So there we go. So that immediately booted through the legacy BIOS support, and then gets us into Debian 12. I don't really care for the graphical installer, so it's going to do the normal text one. There we go. I'm not going to be doing anything fancy. Just want a perfectly generic install that we can get a login shell on, and then once that's done, try to load the agent. Obviously, that part's not going to work, but that's going to be the whole point, and then we'll make it work. So we can see that like it's 32-bit, but like, it still has all of the right drivers and everything, so it's quite happy. Just creating a basic user on there. Fine, US Eastern for time. And partitioning, we're just gonna have it use the default. So use the entire disk is fine. Go ahead. All files one partition, sure. Go ahead. Yes. All right, so we're installing Debian. It shouldn't take too long. It's really a basic install, and I'm not even gonna I won't even install SSH or anything else. Like, we just need the thing to boot and to give us a shell. That's really all we need for testing here. All right. So for anyone who's never tried to install from an ISO inside of Incus, that's how you do it. And for anyone who needs to do it with a ISO that doesn't support booting under EFI, that's how you take care of that part. So it's really security CSM and security secure boot that you want to mess with, and then just add the drive. In this case, I did the boot priority to make sure I boot directly from it, so I don't need to try to stop the boot and select it and all that kind of stuff. So once the install is done, it will probably try to boot straight back into that boot drive. So we just need to turn off the VM, remove the install drive, and then start it back up, and it will be fine. While that's going on, let's just go look at the actual issue. If I can get out of my VM. I never remember the shortcut for, okay, there we go. The shortcut for that. Okay. So, yeah, the issue in question said that Incus currently just looks for a single binary called Incus agent. It actually expects it to be in the host path by default, which is a bit weird. We're gonna want to change that too. We're gonna want to stop making a copy of it because that's kind of wasteful. Want to expose multiple versions of that binary, so that makes sense too. And yeah, effectively, as I said, we want to ship it as something like linux.x8664. It needs to be a drive that, in this case, I was saying bind mounted, but I think I picked up a better way to deal with that this morning, so we'll see. And then the guest needs to be able to figure out which one it is. There's also mentioned there that the guest should be made to compare its agent and kind of reconnect. We'll see if we get to do that. That would be neat. The idea that being that when Incus itself updates, the guest loses connectivity with the host, it should be able to detect that, and when that happens, then try to switch over to a newer version of the agent. The reason for it is if you upgrade to a newer version of Incus and we change something in the API between the host and guest, it would be nice if you didn't need to restart the virtual machines. I don't think that part is necessarily the most critical thing here, but the new design should actually make that easier to do. All right, let's see what's going on with that VM. Scan, no, let's not do that. Sure, just selecting a package mirror. And I think that's when it asks what you want to install, which would be nothing, basically. And still downloading some stuff. Yeah. So the other thing that's worth mentioning is kind of how those shared drives work. For every drive that's exposed to the VM, either through 9P or VirtualUFS, and by default we do both, a binary is like a daemon is running on the host system. So if we look at, say, our Debian 32 VM here, we can see, so that's my command line tool here. That's just started the command. We can see here VirtualUFSD, like a pair of processes that are for the config drive of that VM. And there's actually another one, which I believe is built kind of into QEMU itself for the 9P drive. That works fine. And I think it's reasonable. I mean, we need to have that for the config drive. But for the agent, as we need to effectively share another directory that contains those agent binaries, unless we want to copy all of them in every single one of the config drives, which would be even more wasteful than it is right now. So I would rather not do that. I don't want to have to run another 2 or 3 processes per VMs. That would be quite wasteful, I think. So instead, what I'd like to do is expose, effectively just run one instance of that process for the entire system. So the first VM that starts up will run a VirtualUFSD instance for a given path. So that's going to be like the shared path with those agent binaries. And then all the virtual machines effectively connect to that exact same path. I don't think we necessarily need to do that during this live stream. I can probably just stick to 9p for the live stream, which is built directly into QEMUs and makes things slightly simpler. But that's the intent, is that we want both 9p and VirtIO FS, because not all distros or images support both. And we're not seeing some that don't support 9p anymore, but support only VirtIO FS. So you kind of need both. I just don't want to end up with like another couple processes per VM just for this stuff. So anyways, don't want to participate in PopCon. Okay, now task cells running. There we go. Not installing a full desktop environment. No thanks. Don't even need standard utilities. I just want the basics. Thank you. I basically just want a bootloader and a login channel, which that should give me. Okay, yeah, installing the bootloader now. Cool. Yeah, installing bootloader on primary drive. Dev SDA is fine. Grub, now creating users, and I think after that we're pretty much done. And you might wonder, kind of, why would anyone care about running 32-bit guests? Well, there's kind of two use cases for that. There is the use case of people migrating in existing virtual machines from other platforms, or migrating in existing physical systems into virtual machine or Incus. So in those kind of scenarios, you don't really control what was installed on the source system. So having proper support of 32-bit probably makes sense. It's asking us to remove the install drive. Let's see if we can actually do that. That'd be nice. So Incus config device remove, Debian 32 install. Yep. Okay. Install drive is removed, and now we can reboot. There we go. So yeah, like there's the use case of migrating existing older systems into Incus, in which case we don't really control what they're running. So getting 32-bit support makes sense. The other use case would be people doing development and CI type stuff, where they do need to occasionally test things on 32-bit, and so having solid support for that makes sense as well. That's actually it's that use case that's brought up this current issue with the agent, is people running CI. Okay, so let's go see. We should now have a working Debian system. Yep, sure enough. Okay. So that's Debian installed on 32-bit. Now, obviously, it doesn't have the agent running, and it wouldn't even on 64-bit, because you need to manually install it. So that's where normally you would do mount the drive, and then go here, and then you would run the install.sh script. I mean, we can do it, but it wouldn't work because the agent itself is not the right architecture. So that shows us the issue. Now let's try and fix this mess. If we go look at the Incus code base, actually I can show you that in VS Code. Where is it? There. Okay. So if we go look at the make file here, and we look specifically for Incus agent. Oops. Yeah, Incus agent. We can see that the agent is currently being built statically. So that's the Sigo enabled 0. That means we want a static build of the agent. That makes sense. We cannot have the agent be linked to any kind of libraries. Otherwise, you end up having to run the exact same OS on the host and on the guest, which is usually not what people do. The fact that we can build it statically also means we can build it for different architectures. So that's where I think the make file is probably going to stay this way, because we don't know exactly what architectures make sense. But those packaging Incus should be careful, should actually pick what makes sense in their scenario. So let's see if we can build that thing on on both architectures effectively. So what I'm going to do is Sigo enabled 0, go arch, and we'll want AMD64, so that's the default Intel one. So we build the agent, and we call that incus-agent.linux.x8664. What's it doing now? Trying to require point. Did I mess up my go build syntax? That's quite possible. Ah, okay, yeah, just the order. Cool. Okay, so that should get me Incus agent. Yep, that's fine. And then the other one is i686, I think is the kernel name of the architecture, but not the Go name. What's the Go name? i386? Nope. What do they call it? Is it just called x86 maybe? It is not. Okay, well, I'm gonna have to Google that one. Go Arch Golang maybe? Does that get me the list of architectures? Yeah, Go Arch values, there we go. So we saw MD64 is the Intel 64-bit, that's fine. This is, well, so 386 is actually what we want. That's a weird X32 architecture, I think is its name in Linux. We don't really care about that one. So 386 is the name I wanted. 386. And I think Linux called it i686. Let's see. So if we go back to the VM console, Linux calls the architecture, yeah, i686. So let's do that. Oops. VS Code, there we go. i686. Building that. You can see that I don't build Intel 32-bit code very often in Go, so it's building a whole bunch of dependencies here. And now we've got two binaries. And if we look at them, they're indeed L32-bit, L64-bit. So that's all good. Now, with those two binaries in place, we could just try to kind of fake the future path for those agents. So what I'm going to do is just create a new path as TMP agents. Just bike shedding here with myself, just call that agent. There. Okay, and now I'm going to move the two binaries I just built from the Incus agent path here. Okay, so now that gets me a directory that includes binaries for Linux on both Intel 32-bit, 64-bit. Now, what I would normally do after that is actually want to expose that to the VM. We can try to kind of fake it with a basic drive right now. So let's do Debian 32, call new drive agent, and the source path is temp agent. And we need that to be read-only. True, actually. And it's a disk. It wants a path. So yeah, that's one of the weirder things. But anyways, pass that as smart agent. Okay. Let's see. So now if we unmount this, I'm pretty sure this is not gonna work. Yeah, it doesn't work because I think we always prefix those with Incus something. I don't remember. What's the actual name we use for those drives? So basically the question is kind of what's the name that's being used and like exposed to the VM. First thing first, we'll do a reboot to make sure we get a clean slate there. I thought it was Incus underscore something, but maybe not. I have not played with that feature all that much, so let's see. One of the annoying things is we can't actually list things that are passed to the VM, but we should be able to get it from the agent data. So if we go here and look at agent mounts, yeah, there it tells us. So it does show Incus underscore agent, so it should have worked earlier, but anyways. So now let's just actually just unmount this thing, and I'll create two directories, both agent and config, and then we mount each of the drives into their respective things. So config is here, and agent is here. Okay. So now I've got both the config drive and the agents are both available here. And now if we go in the agent and we look at those files, yeah, it's not installed anyways. I should be able to actually execute this one. It complains because the files are missing and everything, but the binary does actually work. So now I can actually kind of cheat my way around that. If I bind mount this path, so root agent, Incus agent, i686, and move that, like bind mount that over the agent binary in the actual config drive, and now I go here and I run Incus agent. Yep, the agent is supposedly running, so let's see if it works. Yep, so now we're inside the VM through that new agent binary. Okay, so that shows that the general concept works. Like we just need to expose those agents. As I said, I think the way I want to do it is by having a new mount. So we need to also keep in mind that we need to support legacy systems, both systems that don't have the multiple agent thing in place, also systems that already have the agent loader and all that stuff installed in the VM already. So my current plan is, so if we look at what's in the config drive, we can see we already have some legacy stuff. There's a legacy agent that points to Incus agent, that's fine. I think what we'll do is on systems where we have the multi-agent detected, we're gonna turn Incus agent into a shell script. So it's not gonna be a big binary anymore, it's just gonna be a small shell script. And that shell script can then pull in the other config drive or the other share that includes the agent. Like so the new agent share effectively, and then execute the right binary from that. I think that should be okay. Technically, there's a loader script already in here. It's inside systemd, it's called instance Incus agent setup. That could do that, but that gets a bit tricky as far as like picking the right binary, copying it around, all that kind of stuff. So I don't know. I might just do it the easy way right now by having Incus agent itself be a script. The one weird catch is we can't keep those config drives mounted. The reason is for live migration needs. Anything that's mounted prevents the live migration. So that's why right now when the VM actually boots up, it mounts the config drive, then it copies all of its content onto the host system and then executes the binary from there. That's where we might need to do things slightly differently. So I don't know. We'll see what's easiest when we actually look at the code. It's possible that the easiest is actually to modify the loader script itself to do that little dance we need here. So anyway, let's turn off the VM for now and go look at the code a tiny bit. That might make things easier to follow. So I'm gonna be looking, well, actually, if we go look in here, we'll see how that stuff works. So, whoops, not the right instance folder. One server, instance, drivers, agent loader. Okay. So those files are the files that actually are copied into that config drive that loads the agent. As mentioned, that Incus agent script is what creates the run path. It then also mounts the different config drives and transfers the data across. So that would be a pretty good candidate for kind of dealing with that. The issue with modifying that script is that it doesn't do us any good with any of the newer VMs. Well, it only works for newer VMs. It will need to modify the industry builder as well. It's not a script. The script doesn't get refreshed automatically, if is what I'm trying to say. So that's a bit of an issue. I said the alternative is to actually write a new loader script. So have an Incus agent itself be a script, which then picks up the config drive, copies stuff across, and then effectively re-execs the thing. So we could try doing that. Let's do a new file here. Let's call that Incus agent and make it shell script. So what that shell script would then do is we're gonna try, and it's gonna be reusing a bunch of logic from here. Effectively, we need those functions, the mount functions here. Can I copy it across? There we go. Difference here is that we want the drive. For now, we're just gonna be using Incus_agent because that's what I can test with the VM. But it's going to become agent itself once I've modified the QEMU config as well. And so config here becomes Incus agent. It's mounting that. So we need the prefix as well to be copied across. Let me do that. Okay. Okay, so we're creating run Incus agent. We're creating a .mount folder if it's not there already. We've got those two mount functions that mount on .mount. It's all read-only, it's all fine. Mount the agent share. So again, it's going to be a lot of copy pasting between the two scripts, I suspect, because we kind of want the same logic here. Okay, and if that works, then what we're going to be doing is going to be slightly wonky, but that should work just fine, which is we go ahead and actually remove ourselves. So remove the Incus agent shell script itself from that local copy we have, and then we copy the correct one back in its place. So that means we're copying from prefix /.mount /incus-agent. This is the script that runs on Linux, so we know we're on Linux, and then the name of the architecture. Okay, that one we copy over Incus agent here. I don't remember if the other one was fixing the permissions. Yeah, no preserve ownership. Okay, so we might as well want to do that. To just keep things nice and consistent. Not recursive because it's not a folder. Cool. So that's 9. That would now copy the delete on binary and re-exec, and copy the correct binary into place. So that's transfer the agent binary, re-exec the agent. So the last step is effectively we re-exec ourselves. So I should actually use the prefix thing here too. There. Okay. Just trying to avoid hard coding that run Incus agent repeatedly. Just fix that. Okay. All right, that looks better. Yeah. Okay, so we've copied this thing. Once it's copied, unmount the agent share. So we'll just, how do we do that in the other one? Okay, we just do a normal unmount and I'm there. So actually, let's copy that whole chunk. Okay, so that cleans. At that point, we've copied the agent, we've unmounted everything we've brought in, and then we just need to re-exec ourselves. So that's again the prefix, and then it's Incus agent, and after that we pass in all of our existing arguments. straight to the next one, so straight to the actual binary. So that should do it. It's effectively a small shell script that we will write in lieu of the agent itself in the config drive. That means that any existing virtual machine that currently knows how to load the existing agent will just be loading that shell script instead of loading the agent binary, and then that shell script loads the final agent binary, so things should just work. All right. Now, if we go look at Incus agent setup, so let's go into the code for where all that stuff is actually being put in place. Here we go. So that's where we need to actually write, let me check install.sh, that's probably the closest thing. Yeah, there we go. Okay, so install.sh, we're going to be using that as an example, as a template for what to do with the agent script. Install incus.agent script loads from agent share. So we'll just do something like that. The script itself now is called incus agent. Okay, and we write that as obviously Incus agent. It's an executable. It's fine. All right, so that should be okay. Now, the other thing that this logic does is actually write the real Incus agent right now, which is up here. That needs to go away. Because like right now we've got a bunch of logic to see if the agent has changed and what to do and all that kind of stuff. So all of that can go away. I don't think it's going to be quite that simple in practice, because I'll probably want to keep that logic in place specifically for the case where you don't have that agent drive working yet. But let's see what we can do. So currently it looks up, so that's the path where the engine needs to be installed. By default, it says it's true, and then it looks at if the path exists. If it does, it figures out its exact size and time and compares that to the agent binary on the whole system. If that matches, then it doesn't. It decides it doesn't need to do it. Okay. So that's the logic that currently installs the agent binary. In practice, all of that stuff should become conditional on there being the path on the host for those agents. So I think we'll do something like that. So if there's a variable in the environment, which is incus agent path, so we're gonna pull that from the environment like that. If this stuff exists, then we're gonna be just writing our loader script. If it does not, then we can use the existing logic, it's fine. I'm expecting a delivery from FedEx, and I just heard some noise outside. There's a pretty darn good chance that I need to go take care of that. Yeah, someone's at the door. I'll be right back. All right, sorry for the distraction. I'm back now. So as I was saying, I still don't use VS Code very much, so just gonna be redoing the indent kind of manually. It's a bit silly, but whatever. Okay, so that's that logic now. All right. So if we've got the variable in place, we're going to be putting the new Incus agent script in place. So that's the logic I did earlier. Here we go. So that chunk, not quite this one, actually, not quite that one. Come on, what is it? No, this one. So this chunk will actually go back up a bit. In here. So yeah, if we have that new environment variable that tells us where the agents are located on the host, then we're going to put in place the new script, because we're going to expect that the share and everything is available and things will work. If that environment variable is not found, then we assume it's a legacy setup that only has a single agent, and we just go through the normal logic and modify it. So I think that's going to be the most flexible. Like, I don't want to needlessly make it hard on distros that can't ship multiple agents either. So I think that makes it the most flexible here. It is complaining a bit about use of package FS, not in selector. I guess it's my first use of FS from here. Okay, sure. Does that build? Looks like it might. Cool. All right. So the first thing we'll make sure is that nothing has changed effectively. So I'm going here to a shell, gonna become root on this dude. Yeah, sorry, I don't have hold music for when I'm not around. I'm usually trying not to have to leave and deal with delivery people, but I ordered a new switch for my data center setup, and given the value of those things, they don't really want to just dump them in front of my door. There's a visitor coming here. The cat is making it onto the bin bag behind me. Anyway, I'll show you the cat in a few seconds once it's actually settled in. Cool. So at this point, I want to just move the binary over my normal one, and then I'm going to be restarting Incus D. Oops, Incus. Oh, actually, you might see him. He just went for the pillow instead of the bin bag, so you get to actually watch the cat in the background then. Alrighty, so Incus has been restarted, and what I would do at this point is just launch a new VM. Because remember, I've not actually set that environment variable anywhere. So at this point, we should be in the legacy use case where you launch a VM, it should use my normal Incus agent from the system, and that should just work. And it does. Okay, cool. So nothing changed here at all. It's just behaving as expected. Now turn off that VM, and I'm gonna be changing my Incus loader script a tiny bit here, which is that's effectively what the packages will need to do. So we got that loader script here, and then we'll do export Incus agent path, I think I called it. So we'll do temp agent. There we go. Now, if I restart Incus again, it's gonna get me through that script again. And now we should be hitting that different code path in that we just added. So it's gonna hit this Incus agent path, it should exist, and it's gonna now start copying the new loader script instead. Just to make sure, let's start v3. So this one I expect to be broken. The reason why I expect it to be broken is that no config share code agent was never attached to it, because I didn't write that logic yet to do it on the Incus side, and I didn't do it manually. So if we let it boot a bit, it should just completely fail to give us a working agent. Yeah, it doesn't actually show us anything useful on the console, other than it's trying repeatedly to start the agent and it fails. So that's fine. That's actually what I expected to see with this guy. Now, if I do device add, and we add the same agent drive to v3 that we did the Debian one earlier, and start it back up, in theory that should work, because now the loading script should locate that that extra share and should execute the right binary from it. But we shall see. Okay, so it did work. And we won't be able to tell what actually happened. The agent, because it copies itself on top of the binary, but on top of the shell script, it just looks like normal. But what should be different at this point is if we start the Debian one, so Debian 32, that one should actually work now, because the exact same logic will happen, but this time it's going to select the 32-bit binary automatically, and we should get a working agent. Maybe. Let's see what's... Oh, no, I know why it doesn't work. Okay, that makes sense. I never actually ran the install script, so there is no systemd unit that's trying to run all that stuff automatically. So let's see if we can't make it work. So I'm just gonna do the normal agent install process. So mount the config thing, run install.sh, reboot the system. And this time it should actually work, hopefully. Okay, we see it booting. And on a login screen, okay. So login screen, it works. So now we do have the logic to ship multiple different agents for different operating systems, different architectures, and have them automatically be used on startup, which is great. The problem right now is I have to manually pass in an agent drive for each of them, which is not good. It also means we're leaking, well, not leaking, we're using a lot more of the UFSD type processes than we should. If we go look at agent, yeah, so we've got those guys here running, 2 per VM, because one is a child of the other, I believe. Yeah, there we go. So 2 per VM to just expose those agents. That's not good, obviously. Instead, what we'd want is for those agents, the drives to be automatically passed through. Doing that with 9p should be pretty easy, but UFSD is going to take more work, and I'll do that off camera. But let's see if we can't get the 9p side working. So anyway, I'll just start with turning off all those VMs. V2, V3, there we go. That's it, V3 twice, that's not gonna work well. Anyway, stop V2. I think the Debian VM is having a hard time shutting down for some reason. Not sure why. Or maybe it doesn't have an API handler. Anyways, let's just kill it. There we go. Cool, so all the VMs are off now. And the next step is gonna be going in here. And we'll change, so yeah, if I can get out of my file search here and back onto the Explorer, we'll go and modify the shell script. And instead of doing incus underscore, which is the prefix used for the user-controlled mounts, we'll just use agent, which is what we'll be using internally for this one. And now what we need to do is actually have a 9p drive called agent. So if we look for, where is that, in templates, I think? Probably in templates. And then look in here for 9p maybe, or for config. Yeah, config is not the best, the most convenient thing to look for. Yeah, that's not the one I want. Trying to remember what that stuff is. Because it's effectively a chunk of config for 9p that I want to modify, but I don't remember where we generate that. If we go look at the config for one of the VMs, it's like demo Debian QEMU config. And we look for, say, 9p in here. There we go. We see config drive 9p, which is kind of what I want to get to. And we want to add a second section of that, but for the agent. Anyway, based on the comment, I should be able to figure it out now. So if I do search on config drive 9p, yeah, there we go. So those are the tests. That's the template. So that's where it comes from. Okay. And we can see it's called for each of the protocols. So it's not quite what we want. Let me see what are passed in. Drive. Okay. Mount tag is fixed. Okay, so we can't just mess with that. Because it would be kind of neat to just reuse the same logic multiple times. QEMU drive config out. So we might just, since we use two, we might just add a name for it. So that would be config usually, but yeah, I think that we could just call it name and then use the name both as the mount tag. So here. And also just do shared whatever drive. So that would be shared name drive. Okay. And I believe there are tests for this stuff too. So we're gonna need to just go here and modify the test a bit. Checking how it's called. Yeah, so we want here to pass in the name again. Pass that as config. So that's shared config drive. For the other cases of config drive, I need to fix this one. Okay, same deal, we need the name here. We've got a bunch of abstraction around generating those QEMU configs, so that's what I need to go and tweak here a bunch. I think there's one more maybe. Yeah, there's one more here. Shared config drive 9p, and again, name is config. Cool. All right, so that should take care of that stuff, so that the tests actually do pass. Now, to make things still behave, I need to locate all the callers to QEMU drive config and make sure that we do pass the right argument always. And yeah, it's the opt specifically I want. Okay. So that's this file, it's fine. Well, that's a test. Yeah, we modified those, that's the template, it's fine. And then we've got the callers here. So that's the existing stuff. So we'll just call that config and call it done. And same deal here. Name is config and calling that done. Let's see if it actually builds. In theory, that's a whole bunch of changes for nothing. Actually, those are QEMU dev up, so that's not actually the right place for that bit. It actually needs to go down here. Oops. Okay, fine. Name config. Okay, and the other one was here, same issue. Okay. All right, and I messed something up in the template. So line 709, yeah, obviously it's opt.name that I want in both locations. There we go. And that should now be a whole bunch of changes for nothing. That is like effectively all the codes are just passing the exact same values, all the tests and everything should behave. But what that does let us do now is actually call this chunk again. So the 9p specifically, to pass in the extra drive. So I'll just copy paste that chunk. I'll clean it up later when I do the Virtio side of it, but we'll just do a comment saying pass in the agents if Incus agent path is set. So similar to the other logic, we need to do a quick check that we actually do have that stuff in place. So Incus agent path. So if the environment variable is set, and then we'll add the extra drive. Okay, if not, we don't, because it will just use the legacy behavior and it's gonna be fine. So we allocate a new entry. It's perfectly fine. What's it complaining about? That's get n, not get n, sorry. Okay. We allocate a new thing. This one is actually called agent here. And the path that is being shared, it's not the config drive mount path thing. It's instead the host Incus agent path. Okay. So that should work. Let's see if it builds. There's some extra complexity that could fail. For example, we do have AppArmor wrapping our VMs. So it could be that I need to modify AppArmor to also accept that particular path. Otherwise, the VM might fail starting, but we'll see if that is an actual problem or not. So moving the binary, restarting Incus. It's taking a while. Okay, fine. Let's see. So those guys still have the agent. Should remove it. So we don't need that. Like we shouldn't need that path anymore. That extra share anymore because it should be coming out of the box. Okay, and this is failing to start. Duplicate ID QEMU config. Right. So I missed something in here. Yeah, I did. Pretty obvious one, actually. I should have got that one. So this is QEMU. And we want ops.name to match the rest and save that. Now there's a good chance that the tests are going to be mad at me. So let's go look at the tests. Here we go. Do they all? Yeah, they all check for QEMU. Actually, QEMU_config should be fine. Yeah, the test should be okay, actually. Okay. Like I didn't actually change the naming of the device. I just made it so that it's conditional on what's being passed in. And for the config case, it will be the same device name. So it's fine. It's just now for the agent drive, we're going to get to have a different name. Okay. Don't know if I missed more things. I should probably have looked at the rest of that function, but let's see. Okay, still failing, but it's not failing with a QEMU error now, so that's potentially AppArmor hitting us. Let's see. So if we look at the logs for that VM, yep, permission denied. Okay, so that's fine. We're hitting AppArmor effectively. If I look at my kernel output, we should see a pretty clear denial. Yep, there we go. AppArmor is not allowed to access the agent directory. Cool. So that makes sense. I was actually kind of expecting that one. So let's go modify the AppArmor profile. So if we go to AppArmor and then instance QEMU, that's the template we need. And that's where there's going to need to be an extra entry specifically for the agent. Now I'm just checking if there's anything else we have already. Why is that in here? That makes no sense for a VM. Okay. Yeah, let's remove that chunk. Not sure why. Do we even expose user NS? No, we don't. Okay. Which was like a weird leftover from container stuff, so I should probably get rid of that. Okay, so that's raw AppArmor, library path. Just checking if there's anything in there that lets us easily just pass in extra random files or paths that we need access to. It doesn't look like it. So what we'll do is an extra chunk in here. That needs to be conditional because we might not have that path. So it's going to be if agent path. So if it's set, and what's the syntax again? Yeah, okay. So that's the actual syntax for a conditional block. And then we will want effectively that agent path. So that would be something like that, agent path slash any binaries inside of it. We allow reading, mapping. I think that what's K? Oh no, K is locking. We don't need locking, I don't think. I'm confused by the AppArmor mask stuff again. We definitely don't need write. We might need mapping. Actually, the error from earlier would have told us what flags we need. Denied R. Okay, so it just needs read. Let's start with that. And obviously, I need to actually expose what agent path is. It's currently not exposed. So if we go here and we look for, I guess, QEMU in there. Yeah, QEMU profile, there we go. Oh, that's where user NS is exposed. Yeah, that makes no sense. Let's remove that. Now we've got agent path, which is here, and we'll just define it as agent path. And we'll do the same thing as OVMF because it's effectively very, very similar logic. So agent, so effectively var. Like, unlike OVMF, there's no fallback for agent path, so it starts with an empty value. Then if we have Incus agent path, we do agent path becomes the expanded path of this guy. It's big, so that symlink dance I'm doing here is because AppArmor always evaluates on the final resolved path, not on the symlink. So say you point Incus agent path to a symlink, and well, if it is a symlink pointing somewhere else, then if we don't do the full resolution, then it will still fail to access because the paths won't line up. So yeah, evaluating all the symlinks is fine. Then if that evaluation fails, then we return an error. Otherwise, that means our agent path is now set properly and being plumbed through. So it should be okay. Let's try now. Okay, messed up something, 9226. What did I do? Did I forget a comma? No, I forgot a colon here. Okay, fine. So this is building now. Okay, all good. So let's move the binary, restart Incus. And let's see. So can we start the Debian VM now? No. Why not? And it still says that that AppArmor rejected access to temp agent, which is kind of odd. Let's look at the AppArmor profile for that VM. Incus security AppArmor profiles Incus demo. Okay, demo Debian 32. Okay. Okay, let's see extra binaries. Yeah, it's here. Temp agent. Read. Okay. So why isn't it happy? Let's try again, get the failure again. So, denied. Okay, command system x86 name temp slash agent slash operation fine. Okay. Don't really get why that's not working. Oh. I think it's one of those cases where it's trying to access the path, the directory itself, as opposed to just the stuff underneath it. I don't remember if doing the double. Well, let's see. AppArmor syntax can be a bit weird at times. Let's go instance QEMU. Yeah. So this syntax actually just means the binary is inside the path, not the path itself. Normally doing it double means and anything beneath it, but it might also include itself. So I'm wondering if that works. If it doesn't, I'm just going to do it in 2 lines, one that actually allows the directory itself and one that allows its content, and that would be fine. But it might be perfectly fine to use this syntax instead. So let's see. Just rebuilding the agent again. Okay. And restart Incus. And let's see. Nope, same thing. Okay, and it's complaining about the exact same path. All right, fine. So I don't actually expect us to ever have directories in there, and if we did, I'm not sure I want to have access to that. So let's just remove that syntax and instead command copy paste and do your stuff. There we go. Specifically allow the directory itself to be read on top of its content. So let's go with that, and that should take care of it. Okay, it's built, so let's go ahead and move to binary. And hopefully this time it works. AppArmor can be a bit of a weird beast sometimes. Yes, cool. Okay, so the VM is now starting up. And with a bit of luck, we're gonna get the agent actually running. Let me also start the other VM v3, I think, so that we can make sure that both of them work properly. Not yet. There we go. Cool. Okay, so that's working perfectly fine now. Let's go look at the changes made so far. So there are a few of those. And let's see how we can slice that stuff into commits that makes sense. So the first thing I'll do is actually remove that nonsensical entry in the AppArmor thing. So Incus the AppArmor inst QEMU, remove mention of user NS, because that makes absolutely no sense. Yeah, it's that part, not that part. It's this part, not that part. What happened here? Didn't do that. Okay. Okay. Then next up, we're gonna make a commit for instance QEMU. Make config drive name configurable. So that's before any of that stuff. Don't think it touches this one either. It touches that one here, doesn't touch that, it touches that. Yeah, definitely touches this, that. Yep. Okay, so that splits up that part of the logic out. Now what do we have? We've got the AppArmor stuff to allow access to the agent path, and we've got the agent path logic itself. Okay. So right, let's do a commit on QEMU, add new agent share. So that's the AppArmor side. We're still not touching that. Still not touching that commit, but this one should make it in. That should be in. Okay. That random change of comment I don't like, so that should just go away. Yeah. And then we've got AppArmor itself. So AppArmor QEMU allow access to agent 5. Okay. So that's gonna clean things up. There's one more thing we should do in here. We've got documentation for the environment variables in here. So we need a new entry to cover that one. They don't seem to be in any particular order as far as I can tell, but let's start making things proper now. So agent here, path to the directory, including the Incus agent builds. Okay, so that's that part of the doc. Let's see. There's a packaging doc as well that maybe makes sense to touch on a bit. Incus agent binaries. Yeah. Just writing a bit of a blurb there to kind of describe the two ways of handling Incus agent, and that it's recommended to build multiple binaries of the static Incus agent, putting that in a directory and then exposing that should a new environment variable to Incus. Just putting that in there. Incus D. In this scenario, the agent should be a static build of Incus agent from the primary architecture of the system. Multiple agent setup. So to provide multiple builds of the Incus agent binary, bring support for multiple architectures or operating systems. To do that, the Incus agent path environment variable should be set for the Incus D process and point to a path that includes the Incus agent builds. Those builds should be named after the operating system name and architectures. An architecture, for example, incus-agent.linux.x8664 for the 32-bit, or I'm just going to provide both that way. Actually, I'll also provide ARM for good measure. So Linux, that would be AR. Let's do the Intel 32-bit first. Or Incus agent Linux AR64. Okay. So that just adds a bit of documentation for anyone doing packaging for Incus, so they know what to do and can build those extra agent binaries and put them in place. All right, so saving that, I can add that stuff to doc and Incus agent path. Okay, so that's good. Next step is just gonna be doing a quick static analysis check, making sure things behave. You'll notice that with this change, we do save the space, that's good. And we do do provide the multiple binaries based on the architecture. That's obviously works. What it doesn't do is do anything against, like around being able to re-exec. I'm not too sure how I feel about that. Like there was kind of good points both ways. On the one hand, it would be convenient if it could handle a re-exec to fix potential issues. But the downside too is that if something is wrong with the newer version of Incus running on the host, then you might end up just losing access to all your VMs at the same time. So that's not necessarily ideal. Okay, there are a couple of small issues here. Let's just go and fix those. Driver QEMU at line 89. What's it oh, okay, so it does actually want its new thing. Sure, fine. Let's do that. And then some variable shadowing. So let's see. So it says that fs is already used. What's fs? Okay, it is an actual import. All right, cool. So we'll fix that. Just trying to figure out where that stuff is defined. Yes. Okay, what line was that? It was 2605. Okay. Can we do just agent path again? Well, actually, yeah, agent file, let's call it that instead. I'm just gonna fix the rest of them for good measure. That actually uses a pretty nice trick called go embed, which allows for files on the file system to be embedded in the binary at build time. That's how we get to have those files nicely editable outside of the code and just, but still be able to load them kind of whichever way we want inside of the code base. So that's pretty nice. Okay. So just need to commit that stuff now. Let's just do incus d instance QEMU fix variable shadowing. Like we've definitely made our CI quite a bit stricter lately, and it's configured in a way that only tests whenever new code is added or whenever code is changed. So there can be a lot of existing issues within a file that just is not immediately reported. The reason is that because we made it so much stricter, we'd literally get thousands of errors otherwise, and we'd never get anything merged. So with the current configuration, it forces us to kind of clean things as we go. So every time we touch a file, it starts reporting more issues, and we go and fix them. Obviously, we're doing that for the least critical checks, like anything that's like more serious. We've run through those already. It's mostly for the kind of code style type thing that we're fixing them slower. Okay. And very good. Looks like it passed the same test that failed earlier. Yep, all good. So I'm not gonna be pushing. I mean, I can push it, but I'm not gonna actually be. I'm not gonna be opening a pull request for this just yet because I do want to take care of the Verta UFS side of things. That might take me a little while longer to figure out because, as I mentioned, I don't want to have a Verta UFSD process running for every single VM. I'd like to have a global one. And part of looking at that got me into the fact that we are currently storing all of those sockets and all that kind of stuff into a log directory, which doesn't seem really right. So I want to also fix that. So anyways, I'm probably going to be spending the next couple hours doing some amount of code reshuffling in Incus. I think I'm going to change things to have not only stuff in varlib Incus. So currently we've got varlib Incus for the most of the actual storage long-term thing, We've got var log incus that's used for both logs and for socket files, which is wrong. And we've got stuff in var cache incus, that is things like a copy of the image server list and that kind of stuff. The things like the PID files, the sockets, that kind of stuff that's used amongst other things to access those shared drives, that should not be in a log directory. That doesn't make sense. So that stuff should move to a new /run/incus instead. That would make a lot more sense. And that's what I want to actually introduce first. And then once I've put that in place, that gets me a location to put the VirtualUFS thing in. So that's what I'm going to be doing in the next probably few hours this afternoon. Just getting that stuff kind of reshuffled, moving, like splitting those files so that they are in the right location. Then that unblocks the VirtualUFS side of the agent work, at which point I can actually push a pull request for it. So that's the idea. And yeah, once that's done, that will leave us with just 2 remaining issues for the 0.5 milestone on Thursday. So assuming people don't file a whole bunch more bugs, because obviously we've been fixing a bunch on the side, we should be in pretty good shape for 0.5, and that should be one of the kind of busier but also kind of more mature, kind of cleaned up releases. So quite excited for that. And I think that's it for this live stream. That's it, almost like an hour and a half, so it's probably long enough. And hopefully you learned a bit about kind of the internals of how virtual machines work in Incus, like how we actually get things like the exec session and files and all that kind of stuff working by using those shares, using vsock, running an agent instead of a VM. And yeah, how things are going to get better by having support for, in theory, all the different operating systems and architectures you can possibly dream of, at the same time as saving some of the resources. All right, so that's it for this one. If you've got any questions, feel free to leave them down below. You can also go on the community forum. We've got a whole bunch of good threads around Incus there lately, so that's definitely great to see the community kind of picking things up. If you see bugs, file them on GitHub, and otherwise, I'll see you most likely in the 0.5 release video later this week. Thanks a lot for watching. See ya.